All right, everyone. Thanks so much for coming today. My name is David Molnar. I'm here to talk to you about Microsoft Security Risk Detection, which is a new product from Microsoft to help you ship secure faster. Just a quick thing, this is sort of a 200 level session. You're going to learn about the product. You don't need any security background to do that. Developer background is helpful, but my goal is to give you next steps for your journey. I'll show you our Windows testing, which is generally available, and I'll talk to you about how to get it. I'll show you our Linux preview, which is now open for anyone who wants to join. So if you have Linux things you'd like to test, we're there. And I'll spend a little tiny bit of time on some of our future plans where we are recruiting what we call early adopters. This is a pretty intimate crowd, so I would encourage, if people have questions, please just either raise your hand or come up to the microphone during the session. I'm going to be mostly going through a bunch of demos of how this works in your workflow, but I'm happy to take questions and help tailor this to your needs. I'm here for you. And I'll be here after the session for as long as anyone wants to talk. So when I talk about what we've done, this is the culmination of a journey that began almost a decade ago. I worked together with some of my colleagues at Microsoft on the problem of how do we secure the software Microsoft brings to you. What can we do to find buffer overflows, security critical issues, and fix them before they hit you, our customers? What we found was that certain kinds of artificial intelligence underwent a sea change during that time. Questions that used to take days or weeks to answer became answerable in seconds. And we built a system that applied that to the problem of finding issues in Windows. 2006, we published the first results, and we found that this is something that we could really take to production. By 2009, that technology had found a third of the security issues during the development of Windows 7. And over the next couple of years, we rolled it out to more and more products. The challenge with this is always that adopting it was a pretty heavy lift. 100 different options, lots of tweaking, and of course, tons of compute power. If you need to buy a 400 machine lab just to get started, that's not going to work for a lot of people. What we realized is with the power of the cloud, with Microsoft Azure, we could roll up all of that compute power, all of that expertise into one package that you could adopt. And we started what we called an early adopter program in 2015, where we reached out to a small number of people and said, we're going to experiment with a new way of working at Microsoft. We're going to experiment with making something available from the very earliest stages to get feedback, to see how it works for you, and sort of co-create a new experience. By later that year, we actually had helped our very first customer find some issues, and you'll hear more about them in just a minute. And we started moving to a broader preview in 2016, culminating a year ago here at Ignite, where we opened the doors and said, okay, everyone is welcome to come in. And since then, we've grown the offering. We've added partners to help you adopt this kind of transformation, to help you staff in order to put it into your process, to help you come up with new scenarios for things like IoT, for things like DevOps that may be something that you're looking for. And today, we are now announcing our general availability for Windows testing and a preview of Linux testing as part of Microsoft Security Risk Detection. So I want to start by just giving you a kind of a case study of how this has helped some customers. So how many people here write software or are in a business that depends on software? Okay, a good number of people. And for how many people, if that software went down, would be sort of bad for the business? Okay, all the same people. It's kind of a silly question to ask, but that's why. So I want to share with you a story of how we helped a company called OSI Soft. OSI Soft is a Microsoft partner. They make software just like you. The software they make helps people manage factories and critical infrastructure. And they helped one of their customers move all of their data into Azure in order to improve their business processes. And while that customer isn't exactly a power plant, it's critical in its own way. And I'd like to share that story with you now.
Hi, my name is Brian Favor, and I am the brewmaster of operations for Deschutes Brewery. We know financially we need to be able to take on this investment to build a second brewing production facility is a big undertaking and big financial investment. So it's very important that we're able to really maximize our capacity and efficiencies. And so that's when we reached out to OSI Soft.
Project Springfield has really allowed us to test our product in new ways that we haven't been able to before, given the new technology from Microsoft. We'd give a job to Springfield, we'd get the bug report, we'd do our actions based on whatever the report would tell us, and then we'd resubmit the job again and hopefully get 0.
Having a project like Springfield to assure that our data systems are going to be up and reliable and available to us 100% of the time is critical for us to be successful.
So that was an example of a company that's moving all of their operations onto Azure, making decisions using machine learning, and cutting 30% off the time to brew beer. So as I said, not a power plant, but still pretty critical infrastructure in its own way. Now, what you saw was an engineer from OSI Soft talking about how he used this technology, and you're going to see it in action in just a minute, to test every aspect of a new product they have that helps their customers suck data into Azure. That's a product that connects to everything on a factory floor, speaks a whole bunch of different protocols, and if something went wrong, could stop the data flowing, which would then stop the beer brewing and stop the business. So what we were able to do is help the company ship faster. We're able to help them scale security testing to a globally distributed development team. And we were able to help them have greater confidence in the solution they're providing to their customer. Well, how does that work? Well, our technology works on binaries. It doesn't require source code. We can work with the same thing that you are about to ship. We can work with third-party code, open source code, that you're depending on in your solution. We create multiple different technologies for testing. I'll go into detail about the artificial intelligence I've personally spent a decade on, but the beauty of the cloud is we can create a testing lab with as many machines as we want. If a new method comes up tomorrow, we just add a couple more machines to the lab. And so that portfolio approach allows us to stay ahead of the curve, working on your behalf, stay ahead of the research working on your behalf, to understand what the best way to test is and how to deliver that at scale, where you don't have to change what you do. You just upload the software the same way you always would, and it just gets better. We've also put into this Microsoft's experience in understanding what bugs are really serious, and I'll show you that in a minute as well. Not every bug is equally important. How many people here have a security bug bar in your organization? Like they have some idea of like when a bug is a security bug and you have to fix it. Okay, a few people do. For those of you who don't, we offer something that will allow you to help set a bug bar for your organization. Allow you to say, look, if it comes out and it says this, you need to fix it. You don't need to investigate. And that's something that you can depend on because it's reliable, it's the same thing every time. Our goal is to help people do security without being security experts themselves. Our goal is to help people scale security across their entire development process. And then once you have the reports, our technology provides test cases. We give you the actual test case that causes a crash or causes a security issue. There are no warnings. There are no possibilities. There's a crash or there's not a crash. And you can fix the code if you wrote it yourself. If you have a vendor that you got the code from, you can make the vendor fix it. But the beautiful thing about the Microsoft platform is we actually have a number of platform features that help you contain risk, which I'll talk about at the end, that give you options as an enterprise architect, as a developer, as a business owner, to really understand, how do I live with the fact that I depend for my business on this piece of code that was written in the 90s? And the person who wrote it is no longer with us. And this thing is completely unintelligible to every human being who's still here. That's a real scenario. That's something I've run into. In my role at Microsoft, I help teams write better code. I help teams ship more secure code. And I know from experience, we don't always get to work with the code that we wrote. Sometimes we have to deal with something that can't be changed, but is critical. Now, I've talked a bit about this artificial intelligence. I want to show you what that is on a small example. And then I'll talk to you about how we've been able to scale that up to the applications like Windows, like Office, that you care about, and to our customer applications. This is a small piece of code. This code will crash on one particular input. So I think most people can sort of look at this and say, oh, okay, after a minute, I can read the source code and I can say, I know what's going to cause the crash. And you think of that as your code review. So how many people here do code reviews as part of your practice? Okay, a couple people do code reviews. In my work as a security person, I sometimes do security code reviews. And I have friends who do security code reviews for a living. They make a lot of money, actually. They make a lot of money because they can look at code like this and they immediately see the issue, but they can also look at code much more complicated than this. And in fact, they can even often take a look at the binary without the source code, look at the binary in their head, turn it back into the code and figure out what's going to cause the crash. I'm not that good. For mere mortals like myself, I would probably start with a test case like this. I'd put good in, and it's not going to crash. So imagine this is like a third-party code, some open source code you just got off Nugget, or that you depend on for your business, or that, again, is written by somebody in a different organization. And you're testing it, you put in an input good, you put in your regression tests, you put in your functionality tests, and it doesn't crash. But there's still a bug. So what I would do is probably put it under debugger, and I'd start using my human brain to say, well, what is this code actually doing? Well, I can see that it's comparing the first byte to a B. I can then look and say, well, the second byte appears being compared to an A, the third to a D, and the last to an exclamation point. So if I have a debugger, I can single step through, and I can look at exactly what's happening here. And then I can use my human brain to say, well, what would I have to do in order to increase coverage? I would probably need to make that last if statement true. And so in my head, I can reason about this and say, to make that last if statement true, okay, I can see it's comparing the byte to an exclamation point. Well, I should probably come up with a new test case that makes that last byte an exclamation point. All right. And so again, I'm using my human brain to reason about all this. And in order to get to that if statement, I probably need to keep the rest of the test case the same. So I can sit down here and I can go through my debugger and I can think about what I need to do to increase the coverage on this code. Now, I ask people sometimes how long it would take them to do this. So you've got the binary, you've got no source code, you've got a debugger. So how many people think they could do this, in a day? Okay, one person. I sometimes go to security conferences where people, like I said, make far too much money doing this kind of thing for a living, and I ask people, how long would it take you? And I hear, okay, an hour, 30 minutes. Someone said 10 minutes. I asked one of our executives at Microsoft. He told me he could do it in 5. That's why he's a CTO and I'm not. But what we're able to do is we're able to do that in 1/10 of a second. We're able to answer that question in 1/10 of a second using this thing called Z3 that we've been working on for 10 years at Microsoft. And what Z3 does is it answers questions for you. You can write down this question in a way Z3 will understand, and in a tenth of a second, it will create for you that new input, GOO exclamation point. So we've combined this artificial intelligence, which, by the way, is open source, and you can download Z3. It's on GitHub. Everyone here can start using it in your own applications tonight. We've combined that with something we call time travel debugging. How many people here have seen the time travel debugging announcement we just made? No? I have a great pleasure to let you know that if you ever do any debugging on Windows, we've just released time travel debugging as part of the new Windows debugger. And what that does, it lets you go back in time in your code. So the way I like to talk about it is, imagine you have a car crash and you're trying to figure out what happened. From the car crash, well, you'll look at the bumper is broken, or you look at the steering wheel is turned a certain way, and you have to figure out what might have happened to cause a problem. But imagine you had a video of the 2 minutes up to the car crash, and you could step through it frame by frame by frame. That's what time travel debugging does for you. We've shipped now time travel debugging to every Windows developer as part of the new Windows Debugger preview. It's in the Windows Store, and it will be part of the SDK for Windows very soon. And we use that time travel debugging technology here to go through and watch what the code is doing on any sample input you have. And we do that again and again and again to create many different inputs. So you've seen how we can create an input GOO exclamation point that's going to increase our coverage. We can do that again and again and again. And we can feed those inputs back into the program and repeat the process. So I can take that GAOD input I created, I just feed it back in, and I create a whole second generation of inputs. And you can see each generation getting closer and closer and closer to finding the magical input that will uncover the bug. This is all automated. So we're automating, using our artificial intelligence, the same process you would use to debug a program. And we're doing it at great scale in the cloud. And so the result is, in about 2 minutes, we find the crash. So we've automated all of this, and we've put into a workflow that you as a developer, your colleagues as developers, can self-service. The way this works is we turn on the service for you. There's a web portal, which you'll see in a minute, which you can go to. Everyone on your team can share the same portal to collaboratively look for issues. We have tutorials, tips, documentation, all publicly available. You can go to it today, including sample code, which will show you exactly the sort of things we can find. And we can spin up as many test labs as we need. So if you're shipping every 3 days or every 3 hours, it doesn't really matter. You can get a lab on demand, when you need it, on your schedule. You don't need to wait for someone to show up in person. You upload your binaries, we spin up our entire portfolio of testing methods, and we report in real time as we find things. So the minute we find something, it shows up on our website. We also have an API, which we're making available to those early adopters, to do integrations into your build system, integrations into your bug tracking, integrations in whatever's going to make your process faster. You can look at those reports. We tell you how serious something is. And again, you fix, you contain, you ask other people to fix, and then you can just repeat the process over and over again. So when we talk to customers, we hear people say that business pressures are forcing them to ship faster. It's no longer a 6-month release cycle. It's now an every week release cycle. And actually, we've gone through this at Microsoft. You've probably noticed Windows has gone from every 3 years to like every 3 weeks. Our team at Microsoft actually ships every week using Visual Studio Team services. And I just want to show you a demonstration of what the product looks like kind of in that scenario where you might be shipping all the time. So I'm going to show you here, this is a test task in Visual Studio Team Services. This is something you can imagine a manual tester doing, saying, okay, I'm supposed to check the new build, and I'm supposed to upload it to the Microsoft Security Risk Detection Service. So that's part of your VSTS. The other thing VSTS provides is automatic builds and a way to keep the build artifacts in one place. So if you're using VSTS, this probably looks familiar, but if not, imagine that it's whatever build system you happen to be using, whatever you use for your releases. So in this case, I'm playing the part of the person who's supposed to be doing security testing. And what I want you to look for is there are no security knobs to turn in any of this. I just need to know how to build the code. And in this case, I really just need to know how to push a button. So Visual Studio Team Services is building this for me in the cloud. I don't even need to actually have anything outside my web browser. I could be doing this from a Windows 10s machine if I wanted to. And I can just sit there and say, this is the specific build I'm going to test. So I'm going to sit there, and it's going to run for about a minute, and then I come up with a build of the application I'm looking at. This application, by the way, is a sample application where we've planted some bugs. We've actually put issues into it that you can download to see exactly the sorts of things this product can help you find. And then after it's done running, I can say, all right, I'm going to go and pick up the specific artifacts, the specific executable that I built. And I'm like, great, I have a particular build number, so I can associate the testing to exactly the release candidate or exactly the build that I'm interested in, so that I can communicate with the rest of my team precisely and say, like, this is the one that's got the issue. This is the product. We create a virtual machine in the cloud for you. So the product gives you an entire virtual machine to play with. If you have dependencies, if you have kernel drivers, if you have registry key modifications, if you have libraries, you can do all of that. You can install everything. And so now I'm the tester. I'm gone. I've downloaded these artifacts. I'm installing them on the machine. So I've just gone ahead and installed it the same way I would install any code or deploy any code to my application to any virtual machine. And I now say, okay, great, I've got this, this application. It happens to be a small calendar reader. We've written a small application that reads calendar files for you. Again, it's all open source. You can take a look at it. And then I need some test cases. So this particular code also includes some functionality tests. Very simple, basic calendar files that you might use for testing anything that you've written. I'm going to copy those over onto the machine as well. And then you can see it is exactly what I would be doing as a tester in your organization in order to test this piece of code. And again, there's no security knobs, there's no security dials. I just need to know how to fill out a wizard. And so the wizard says, okay, well, tell me what the application is. Just go point to it. So I can say, oh, great, I'm going to go point to the application. Tell me what command you need to run. Show me where the test cases are. So remember, I showed you on the slide, we took one test case, good, and we create a whole mess of new test cases. That's exactly what's happening here. I answer some questions around how long do I expect this to run for, so we can report hangs to you as well. And then I push the button, and we're off to the races. That's it. An entire lab spins up in Azure now. And in real time, you get results. So this is what the results look like. You can see some of them are crashes, some are exceptions. You can filter it down to exactly what's useful to you. In this case, this is a specific, it's a read access violation. It's something that we think is exploitable. We're telling you it's serious. So I, as the tester, can say, you know what, this looks serious. This meets my bug bar. I don't actually know what it is, but it meets my bug bar. And I can create a bug just by copying and pasting information from the product. And I can actually get a URL which tells people looking at the bug how to download the test cases that reproduce it. So this is me filling out a bug. I'm saying if you need to reproduce this, go to this URL, download these test cases, and then run them on the product. So and we actually can group all of the different test cases by the same root cause into what we call a stack hash. So we're saying, go ahead, download this. These are all things that the systems looked at and said it's the same root cause, it's the same bug. And then I, as a tester, can assign it to a developer and say, please take a look at it. Now, a developer then comes in and says, great, I have a new bug. Is this real? Is this not real? Let me go try it out. In just a few seconds, I, as a developer, can go straight to the product. I can then download the test cases. I get a zip file containing everything I need. And I can say, all right, let's unzip this, and I can start running the code on this test case and see, does it really crash or not? And what you can see here is I've downloaded everything. This is what they look like. It includes all of the test cases. It includes all of the logs from the debugger. And I can say, great, I'm going to go ahead and run my application on that test case. I'm going to see if it really crashes. So again, there's no security knobs. There's no warnings. You don't need to have a PhD in security to use this. You just run the test case and boom, it crashes. And I push debug, and up comes Visual Studio at the particular line where the issue is. So the other thing that's nice is you don't need to give us your source code at all. You upload the same binaries you're about to ship or that you've gotten from someone else. But because we give you the test cases, you can run it at home. You can run it with the source code, with the debugging symbols. And just to sort of go over it again, what we give you are these results that for every single problem we find, we group all the different test cases that find the same problem for you. So there may be many different variants that cause the same issue. We group them all for you, so you can all download them and say, great, now I want to see several different ways to trigger the same thing. We then also sort them for you by severity. We tell you which ones are really important and which ones are not. Something that can help you set a bug bar for your organization. And every single one of those comes with debugging information, comes with the results of running the Windows debugger, and gives you something you can download and attach to your bug tracking system. So this is also something you can add to your regression tests afterwards and say, great, I think I fixed it. I want to put this into my regression test and make sure I fixed it forevermore. So that's just an example of how we see this fitting into a workflow where you have to test all the time for security, but you may not have trained security people floating around in your organization. And in fact, with 1 million unfilled positions in the security world, no one can hire enough security people. So our goal is to democratize artificial intelligence for helping people find serious security issues. And we have some understanding, because we've helped people do it at Microsoft, of what it takes to build something like this. So if you're trying to build some of this technology yourself, you'll first have to create a whole suite of different fuzzing methods, different security testing methods. And that can take several days, depending on what you're doing for a very simple thing, to much, much longer. Even if you're trying to work with the great foundation that's out there now, and it's so much easier to do it now than it was 10 years ago, it still takes time. And then we've actually put this all together into a simple solution for you that has a wizard. So this is something that our goal is to make this seamless and easy for you. And if it's not, then I run the product, I'm right here. I want to hear about it. And our goal is to make this possible for people to deploy at great scale over and over again on your schedule. So you can automate everything and put it into your process. And the goal is to get you started the same day. So we're offering trials now. We'll talk about that at the very end. But we're offering trials. We have a preview for Linux available. We are generally available for Windows. We can get you an account within an hour of talking to you and get started. Now, to give you an idea of kind of the scale we're able to get to, here's some data from running that artificial intelligence I showed you on an Office application. So this is an Office application that is opening a blank file, displaying the file, and then closing it. That's all it's doing. That's about 1.4 billion instructions. And 928 million of those instructions are executed after the file starts being read. So it's 928 million instructions that could be hiding a security hole. 928 million instructions that may have something that is an accidental oversight that we have to look for. And in that particular execution, we generated 25,000 of those questions that you saw. And we ended up solving 2,980 of them to create new test cases. So we were able to take this huge ocean and then sort of look at all the different places we could find ways to increase coverage. And we were able to create thousands of new test cases. And then across 200 Windows applications, we ended up running millions and millions of of questions for a constraint solver, and 90% of them were solved in 1/10 of a second or less. So this is the sea change that happened. Things went from being incredibly difficult to solve to taking 1/10 of a second. And that's what we wrapped up for you. Now I want to share with you another customer story about how we've been able to use this to help people who are trying to scale out their teams, even though it's very hard to hire in security. So I've shown you kind of how this fits into a Visual Studio workflow. I've talked to you about the core technology. I want you to hear a little bit more about, from the developer level, how this actually fits into a workflow. And so the question is, how do I scale my team? If I'm trying to have a security team in my organization, I'm trying to scale them out, it's hard to hire, what can I do? And that's a case study from a customer called DocuSign that has used this to help their engineering teams scale and meet the demands of what it takes to grow a business.
My name is John Heisman, and I'm the Senior Director of Software Security at DocuSign. We serve 300,000 companies with 200 million users worldwide, and we're in 188 countries. Security is absolutely critical to everything we do at DocuSign. We build it into every process, and we have to. Modern software development is not simply a question of build versus buy, it's build versus buy and get a bunch of third-party dependencies along with it. And my team have to evaluate whether that component is robust. Microsoft Security Risk Detection ran millions of test cases across multiple virtual machines, completely automated. There was no additional setup required from us. The results were really positive. My team is constantly looking to automate processes while retaining a good level of coverage. Services like Microsoft Security Risk Detection allow us to do exactly that. I'd certainly recommend Microsoft Security Risk Detection to other companies that are looking for scalable, easy to use, cutting edge technology. I've worked in the security industry for 15 years as a bug hunter. Having this type of technology available to us is hugely beneficial to our team.
So what you're hearing is someone who's responsible for a security team in a large organization. So just a quick thing, how many people here are kind of developers? That's your main thing? Is anyone here kind of a security person in your organization? Okay, we've got someone there, a couple people there. The person you just heard from is a security person. He and his team, which is a small team, are responsible for every single request to use third-party code, looking at it and saying, is this good enough to use in my organization or not? That includes every piece of open source code, every piece of mergers and acquisitions code. You can imagine how many requests he gets. And so the question he has to solve is, how do I scale my team, even though I can't hire more people, I can't hire 100 people, without slowing down the business? without having VPs yelling at me about my people are blocked because I need to deal with this thing and I need to know if I can use this open source tomorrow, blah, blah, blah. So they used the solution to test several different libraries, as you heard, and they were able to detect which ones needed special attention, which ones to focus on, and which ones also needed some of our platform features in Windows, like using containers to isolate particularly risky code. And because they were able to do that, they were able to be great partners for the rest of the organization, for the rest of the business, and say, this is something where we use this to figure out where the risk is and help everyone take action to combat it. And I want to just go back and share a little bit of data with you, again, from our experience running this on Windows, where we actually have run this at scale on sort of several hundred applications that ship as part of Windows. And you can see from this is when the bugs are found. We actually are able to run for 23 days and longer, and we're able to see that there's a whole spike of issues found at the beginning. And that helped us figure out how long we should help people run for to know when you've gotten most of the goodness. And we continue to get data from every run to help you understand how to test and where to test with the solution. Now, open source, of course, is something that's very exciting, very important. One of the things I've seen at Microsoft in the last 8 years since I've been here is we've had a complete change in our attitude towards open source. When I first came, it was difficult to get approval to use open source. And now it's encouraged. It's absolutely encouraged. But we now have a whole process at Microsoft for doing governance, of registering when we use it, having people test it, and trying to understand which versions of open source are worth using and which ones are not. How many people here use open source in some way in your organization? Okay, almost everybody, right? Because it's insane not to. What I want to show you now is a demonstration of using the Microsoft Security Risk Detection product on some open source. In fact, some open source that is very easy to get because it's in Nugget. So this is something where we're going to go after libjpeg, which is a very common library that you might have used in some of your endeavors, or someone in your organization might have used for parsing image files. And what I have here is an example. It's just Visual Studio 2017 Community. And I'm going to go and grab Nugget. I'm going to go and get libjpeg. It is the easiest thing in the world to get. That is the beautiful thing about these package managers. It is so much better than it used to be. But there's a little bit of a challenge here. And the challenge is, which version of libjpeg am I getting here? Turns out there's like 4 different versions on Nugget. Some of them are years old. And I'm picking a little bit on libjpeg because it's a kind of library that's had security issues in the past. If you go back and check, there's a thing called the Common Vulnerabilities and Exposures list. Go back and search for libjpeg to be scared. What I'm doing here, what you're seeing here, is I'm just wrapping that library with a very simple thing that reads a JPEG image from the command line and feeds it to the library. So remember, our artificial intelligence just needs one input, and we start generalizing based on what the code is actually doing. So all you need to do to test a library is wrap it up, then you run it. I'm testing that the wrapper worked, seems to work, and then I can just upload this whole thing up into the Microsoft Security Risk Detection and start the testing process. Just push the button and off we go. Now, one of the other things that's interesting is and you can see here, I'm just going to go ahead and copy everything, just zip up a whole folder, copy everything over. One of the other things that's interesting while you're watching how it's this easy to copy things over, one of the things we've learned is, even though we can get started with just one input, there's this thing called seed file diversity. Seed file diversity means the more inputs you have, the better your fuzzing, the better your security testing. The other reason I'm kind of picking on libjpeg is that it turns out if you're looking for seed files and a lot of different seed files, and it's a publicly known format like JPEG, I don't know if you know this, but we have a search engine at Microsoft. And that search engine has an API. So what you're seeing here is the results of using our Bing API to go search for seed files, these JPEG files, which we then use to start with the testing. So that's something you can do today. You can get an API key as a developer, and you can start using that as part of your process for qualifying applications or libraries you depend on. And here, just in a few minutes, you can see I've uploaded the seed files, I'm filling out the wizard, I can say, all right, let's go through, point at the application I want to test, point at that wrapper I just wrote, point at the seed files I got from Bing, and all I have to do is fill this out. Again, it's point and click. There are no knobs to turn. There's no security knowledge required. We hide all of that from you and just make it something that can fit into your workflow, into your process. And I push the submit button, and off we go. We're back in business. Just like before, an entire lab spins up in Azure and gets started for you. And we just get going there, and it's just like we saw before. So just to drill down, let's see. This is an example of where I have a third-party library that looks at images, and those libraries are quite common for having security issues. So I was able to use the Bing API to grab seed files, improve my testing, improve my coverage from the beginning, and get better security testing at the end. So that's a way where we're bringing together an entire Microsoft platform to help you with your security testing. However, talking about Microsoft platforms, I've shown you everything so far on Windows, and Windows is what we have generally available. However, we know that not every customer is Windows only. So how many people here are writing for platforms other than Windows? Right? Okay, a couple people. Anyone using Linux in the audience? Okay, we've got someone using Linux. We have a preview open now, available to you to try right now, where we make this available for Linux applications. We've taken the same process, the same sort of workflow, and we've ported it over to Red Hat Linux so that you can use your Red Hat Linux applications. You can test them at great scale with the same sort of workflow that you saw previously. I just want to show that to you here. So in the preview, you can choose, do I want Linux or do I want Windows? And today we're starting with Red Hat because that's something our customers have told us they want, but if there are other distributions of Linux you like, we're here to help. Let us know. And you can see instead of a remote desktop into the machine in the cloud, we give you an SSH command. And here, I'm actually showing the bash shell in the Azure portal that we have, where you don't even need SSH installed on your machine. You can just go SSH to the Linux machine in the cloud straight from the Azure portal. And it's a little hard to see here, but what's going on is I've logged into the machine. I can then download my application onto the machine. So what we've done in the past is we've helped customers create staging areas using Azure Blob Storage, where you can deploy your application to Azure Blob Storage and then download it onto the machine here without ever having to have direct contact between your developer desktop and your enterprise and the machine that we're using for testing. I can then say, all right, I'm going to go ahead and start this application. And I am going to go ahead and fill out and unzip it onto the machine. And that's what we're seeing here. And all these videos are available for people to look at as well, by the way. And I can run it, and I fill out a wizard that is very similar to the wizard you saw previously. But it's something that runs on Linux. And we have the same kind of workflow, same kind of scale, same kind of ability to get test cases to you on your schedule when you need them. And so what I can do here is I'm going to go ahead and just, it's filling out a wizard here. It's asking me, how do I use this? And I'm going to go ahead and skip forward here. And the result is that you get test cases for your Linux applications whenever you need them. So when you put this all together, what this means for your team, we can give you continuous improvement through our artificial intelligence because we're learning from every time that we run against your applications. We can give you the ability to test whenever you want, however many times you need. And this way you can be faster in shipping and faster in doing your security testing. Today we're offering this product as part of the Premier Developer Support Package. So if you have a Premier contract, you can use that contract in order to get access to this product today. We can also bundle it for you with a number of other Microsoft services, such as SDL services that help you look at where your applications are weak and do an inventory of where you might want to use this. We have testing and development support that helps bring Microsoft Blue badges to your organization in order to help you understand what to do next. So if you need help figuring out how to help your developer teams fix these issues, training on how to avoid having issues happen in the first place, Microsoft has an entire plethora of developer support options available for you that you can use together with this. We also have partnerships with EY and with Leviathan Security Group, where if you need even more services, we can help create a full package for you and your team. I just want to close by talking a little bit about where we're going. So I've showed you the product as it stands today. I've talked to you about the packages we can build around it for supporting you and your team on learning and training to do more. But our motivation is that today we think there's just brick walls between different parts of the enterprise. People who are trying to ship every week are worried because they need to wait for a security review before they can ship to production. The security team has 1 million open positions in the industry, and so it's impossible to hire, and you can't get people to come to your organization fast enough. So you have backlogs of 6 months, a year, or more. And then, of course, those of us who are working in IT, well, if something happens, if there's a hack, it's my job on the line, so I need some protection. Our goal is to build a platform that breaks down those walls. Our goal is that this is the beginning of something where a developer can harden his or her code, the red team can learn from that and sort of feed data back into the platform, and IT can use the entire security platform we're building at Microsoft to protect everyone in your organization. This platform will become the way that we help share information between all the different parts of the company responsible for security of software. I just want to show a very short demonstration of what that looks like of our current platform, and how you can use that data that we get out of this product in order to help you with another Microsoft product. And that's something called Windows 10 Exploit Guard. So how many people here have heard of Emmet or Exploit Guard? Okay, a number of people. So for many years, Microsoft, we've shipped this add-on called Emmet, which allows you to take legacy code, which you can't change, and try to add protections to it. So I'm going to go ahead and show you that calendar reader application. This is the calendar reader. So again, this is an application. We've planted bugs in it. It's a thing you just saw me find issues in. You can see there's a number of things that have those scary red bangs in it. Right. Let me duplicate my screen here. Great. So this is the calendar reader. And I can see, all right, I'm going to go ahead and run the basic calendar. So it says, great, I've parsed the calendar. This is the exact same application I just showed you, has tons and tons of bugs. This application we probably should not be leaving around on our estate without some protections. So I happen to be using the insider build of Windows. I guess I'm a daredevil these days. And I have this thing called Windows Defender Security Center. And in the Windows Defender Security Center, I have this thing called App and Browser Control. and it's got exploit protection. So there's other sessions where you can learn much, much more detail about this. On Thursday, David Weston, the fellow who actually runs this product, is going to be here. You should go find him and ask him all your questions. I just want to show you that I have been able to test this application. I know it's terrible. Now I can do something to it without having to recompile. All right, exploit protection settings. I've got some great stuff for the system, but now I'm going to go after a particular program. And so what I've done here is I have this particular program, but to do that, I just need to say, all right, I'm going to go ahead and add it. I can choose a specific file path. Strangely enough, I've already got it up here to save us all some time, but I can just point it and say, this is the one. This is the one that I want to protect. And then what have I done here? Well, I've actually gone through and I've overridden the basic levels, the basic settings, because I know this is a more risky program. And let me kind of walk through what that looks like. I can edit this. And I can say things like, I know this application is not going to be doing any kind of just-in-time compilation. This is not a Java interpreter. This is not a Ruby interpreter. This thing should not be creating code on the fly. And I know malware typically creates code on the fly. So I'm going to go ahead and say, if this thing tries to do that, kill it. Kill it dead. So great, I turned that on. I know that this calendar reader shouldn't be loading images from remote devices. So I can just say, great, that's not allowed anymore. It's just parsing calendars. It doesn't need untrusted fonts. And so there's a whole set of things that I can do here just as the IT admin, using the information I've gotten from this security testing to say this is high risk. But of course, I still need to use it. I can't get rid of it. So this gives you some platform options to say, great, I've learned what the risk is, now I can do something about it. And there's just one of a series of things we can do on the Microsoft platform to help protect ourselves. And there's a whole bunch of different things. And again, there's a separate session which will go into all the detail of all these different things. But the point is you can now use this feature of Windows 10 to protect yourself from legacy code without having to recompile, without having to throw it out. And where we think that's going, and that's where we're looking for these early adopters, is we see that coming into intelligence, where the intelligence we get from being in the developer workflow helps a red team understand where the issues are or where they might be. The intelligence a red team provides by testing something helps IT figure out where do I need to sort of isolate, where do I need to turn on different features of the platform, and really make it possible for you to become smarter in your organization because of someone else you've never even met. Our goal is for what I just showed you to become something that you don't even need to know the other people who are doing it. There's just this data plane that gets smarter and smarter the entire time that you're working and helps you understand what everyone else in your organization is doing. So what are the next steps? You can talk to us, fuzzing@microsoft.com, anytime. We're always here for questions. I'm here for questions. I'm going to be here right after the session to answer any questions you may have. We're available right now. If you have a Premier Microsoft contract, you can use that contract, get access to it right now. We're generally available for Windows. That means it's a fully supported product, and we can create packages for your entire organization to help you meet your developer support needs. We have a free preview right now for Linux, where we can get you on board for Linux testing, and we're looking for feedback on that, and that's pretty open. That's something we're just looking for more people to get on board and try out. And when it comes to some of these scenarios like the intelligence, web testing, which is in our pipeline, or DevOps, where everything I showed you is manual, we actually have an API under the hood. We're looking to build things into your workflow so it just automatically runs. And part of that is using our data to determine how much testing you need. So we can see, is it a commit? Is it a release? The system should just figure out what you need for you. We're looking for a small number of early adopters to kind of come on that journey with us. And that goes back to what I shared at the very beginning, where we had a small number of early adopters really help work with them closely to help transform their process. So if that's you, please come find me and let's talk about how we can get you on board for that. So with that, I really appreciate your time, and I welcome your questions. Thank you. Yes, if you go to the microphone so people can hear it later.
So does it work also with the web applications, or is it only for desktop?
So the question is about, does it work for web applications? Today, what we have available is for desktop applications on Windows and server applications on Linux. Web is our early adopter. We're looking for people to be early adopters for web. So it's not available yet, but we're looking to sign people up to sort of work very deeply with as we bring out web.
And from a general standpoint, how does it differ from like dynamic testing tools?
So the question is, how does it differ from dynamic testing tools? This is a form of dynamic testing, but what it does that other tools don't do is it's able to reason about the actual structure of the code itself, the binaries itself, in the method I showed you, in order to create these test cases that are informed by the actual code, binary code. So like other dynamic testing tools, it creates a test case that you can then use in your regressions or you can then use in your workflow. But it has this artificial intelligence to it and a scale to it that other tools don't have. Does that help? Yeah. Yes, question?
First of all, will you be able to share the slide decks?
So questions about sharing the slide deck? Yes, absolutely. Email fuzzing@microsoft.com. We can share the slide deck.
So just to understand how this thing works, this tool will spit out all the potential bugs that it sees, right? Not necessarily limited to security issues. Is that right?
So the question is, what bugs does it spit out? Anything that causes a crash, it will spit out. So we then look at those crashes and try to tell you which ones are security issues. But it is absolutely true, we do report anything that crashes.
All right, okay.
So you can think of this also as like a reliability testing as well as a security testing.
All right, okay. And I had one similar question to the question the gentleman asked. The other one being tests are it's a prerequisite to have this thing run, right? I need to have at least a decent coverage of tests. The application that you just saw during the demo were relatively small, right? Mm-hmm. But typically our applications are much bigger than this.
Yes.
So in order to derive the benefit, we need to have a substantial bit of test coverage in terms of functional testing.
So the question is, how much test coverage do we need to get started? And the answer is we can get started with whatever you have.
Right.
The more you have, the better, of course, but you can get started with just something basic,
right,
and the technology can still create additional coverage and additional test cases.
Okay.
What we really need is for you to sort of help guide us to where to get started. So you remember, in the wizard, you had to point a particular application,
yeah,
and give us some command line to run.
Yeah.
We just need that.
All right, okay. Thanks.
Great, thank you very much. Any other questions? Yes?
Round-tripping VSTS, so we're, again, it's part of build tasks that would automatically drop a binary, generate the results, and I see that's something on the roadmap.
Yeah, so the question about round-tripping VSTS, that's part of our early adopter program. So where we are right now is we have that working kind of, we are looking for a select few early adopters outside Microsoft to try that out in the next few months. But yes, that's absolutely where we want to go, because the DevOps scenario for us is the full round-tripping. And then once we have that working, it's about the intelligence to say, well, maybe we don't need to have the same amount of testing on every single run, or the same amount of time on every single run. But that is absolutely what we see inside and outside Microsoft to help people do this at great scale.
And I assume we pay for whatever VMs get spun up to do the fuzzing, and that's basically once we have a Premier contract.
So the question is about the payment. Today in Premier, this is sort of priced as an alternative to a code review, because right now it's a manual process you would use instead of, or an adjacency to a code review. For the DevOps, we would be looking at a different charging model most likely, and then it's going to be some kind of consumption, and we can talk about exactly how that works. And that's also part of why we want an early adopter program, is to get feedback for what would work for you and your organization.